Hi everyone, good day. I'm Jordan Iwano from BSME 1 and I'm a non-regular student, so in this video, I'm going to discuss the basic concepts of crystal structure. So before that, what is crystal structure? Crystal structure is the most complex and intuitive subfield in crystallography. Every atom's location in a crystal is known, as well as the translational access that enable the structure to recur. The variety of crystal formations are endless. So, here are the basic concepts of crystal structure. First, the 7 lattice system. So, I'm going to discuss first the 7 kinds of lattice system. So, the first system is the triclinic system. Triclinic system is the least symmetrical crystal system exists. The length of all 3 axes is the same, and they are all inclined toward one another. The numerous crystal formations are in the paired faces according to 3 inclined angles. Second is the monoclinic system. This system has 3 axes, 2 of which are at right angles to one another and 1 of which is inclined. The lengths of the 3 axes vary. Basal pinacoids and prisms with the angled end faces are included in the monoclinic system. Third, the orthorhombic system. It consists of 3 axes that are perpendicular to one another. Different lengths exist. The orthorhombic system contains many crystal structures such as pyramids, double pyramids, rhombic pyramids, and pinacoids based on the rhombic structure. So, the fourth is the trigonal system. Trigonal systems' angles and axes resemble those of hexagonal systems. There will be 6 sides at the hexagonal system's base, the cross-section of a prism. There will be 3 sides in the trigonal system based on the cross-section. The fifth is the hexagonal system. So, hexagonal system has 4 axes in it. The 3 axes designated as A1, A2, and A3, and all located at a 120 degrees angle within a single plane, known as the basal plane. At a 60 degrees angle, they cross one another. Other axes are right angled and intersected by the 4th axis. Double pyramids, double-sided pyramids, and 4-sided pyramids are examples of crystal structures seen in hexagonal system. So, the 6th lattice system is the Tendragonal System. There are 3 axes in it. The length of a primary axis might be either short or lengthy. The 2 axes are parallel and have the same length. The 7th and last lattice system is the cubic system. Out of the 7 crystal systems, the cubic system has the highest symmetry. The lengths of all 3 angles are equal and they connect at right angles. Octahedrons, cubes, and hexacrystals of a cubic system are based on the square inner structure. So here are the second basic concept of crystal structure. It is called as the periodic array of atoms. The discovery of X-ray diffraction by crystals and the publishing of a series of straightforward calculations of the characteristics of crystals and electrons in crystals mark the beginning of the serious study of solid-state physics. Why do we prefer crystalline substances over non-crystalline solids? Crystals are the finest means of expressing the significant electrical characteristics of solid. Consequently, the most significant semiconductors' qualities depend primarily on the host crystalline structure. Because the rectangular periodic atomic order of the material has a substantial impact on the short wavelength components of electrons, particularly non-crystalline materials, glasses, which have a role in optical propagation because light waves observed on average across the order have a larger wavelength than electrons and do not have the locally prevailing less regular arrangement. So, the third basic concept of crystal structure is named solids. So, solids are crystalline solids described as having highly organized arrangement of their atoms. Ions and molecules is very tiny structures. A crystal lattice made up of these organized tiny structures explain the solid's structure at any given position. So, the fourth basic structure of crystal is the types of crystals. Here are the 4 kinds of crystals: molecular, ionic, metallic, and covalent crystals. So first, what is covalent crystals? Covalent crystals are crystals that are joined together by covalent bonds, are known as covalent crystals. Since the atoms share electrons to form the link, these bonds are very strong and fragile. These materials are particularly difficult to break because the atoms are tightly and covalently pack and link to each other. The second type of crystal is the ionic crystals. Ionic bonding is used to form ionic crystals. Solid crystals with a high melting point known as ionic crystals are kept together by the attraction of ions, especially positive to negative. The salt shaker contains the most well-known ionic crystal. So, the third kind of crystal is the metallic crystals. So, metals bind together to form metallic crystals, which are composed of metals. These crystals, which have a glossy look, include iron, copper, gold, and other minerals. So, the last type or kind of crystal is the molecular crystals. So, molecular crystals are the least durable of all the crystals, which are held together by flimsy hydrogen bonds and have low boiling temperatures, are comparatively simple to disassemble. Some were even easy to disassemble with your hands. A wonderful illustration of molecular crystals is a dry ice. So I'm going to discuss the last basic concept of the crystal structure. It is namely molecular solids. It's a form of solid in which van der Waals forces, rather than ionic or covalent connections, hold the molecules together. Ionic or covalent connections are stronger than dipole forces. Molecular solids often have relatively low melting temperatures, typically less than 300 degrees Celsius. Due to the comparatively weak intermolecular interactions, organic solvents tend to dissolve molecular solids. The majority of the molecular solids are low density rather than soft electrical insulators.